Financial Modeling, Topic 15, Option Valuation and Hedging, Section 3. We are going to value options using a Monte Carlo simulation. I'm going to specifically value a short-term call and a put on a Google stock in 2012. And you'll see in a later topic why I picked that particular old option, because at the time I was thinking about taking a position in that option. So on the day that I wanted to value this option, I went to Bloomberg and I got the following screen. And this is a options monitor in Bloomberg. I just type in OMON and type in the Goog stock symbol, and it comes up with this option monitor. And you'll notice here that the option monitor is set up so that we have calls on the left. So these are my calls. These are my puts. And what you see is each one of these dates is a delivery date or maturity date of the option. So for example, here are the March, April, June, September, January, and then January the following year calls. And then on this side are the puts. And then what you see is for each delivery date, we have calls for March, puts for March delivery. And by the way, this is as of February 28th, and these are March 17th calls and March 17th puts. And what you see is I have it set up so giving me, say, just 3 strikes for each one of the delivery dates. I specified that. There are many more strikes. So for example, I see a 610 March call, a 615 call, and a 620 call. And you can see those calls are selling for, if I just look at the last prices, looks like between $7 and $13. And the puts are selling between, say, if I just look at the last prices, between, say, $8 and $13. So what we're going to do, I want to specifically value the 615 March call and 615 March put. So let me circle these. 615 March, 615 March for the put. And again, these are market prices. So the bid ask on the call is $9.90 bid, $10.20 ask. So if I want to sell it, I get $9.90. If I want to buy it, maybe $10.20. So the last price there was $9.90. So you look like you can buy it somewhere between, say, $9.90 and $10. It's about a $10 option. And this one's a little bit more. It's selling for $10 and a little bit. So what I want to do is actually value these options, which both are selling at about $10, and see if I can value them. So what I need is I'm going to need a model, and the model I'm going to use is the a Monte Carlo simulation. And I talked about this in the last section. What I'm going to do is I'm going to simulate 10,000 possible prices of Google about a month from the date of this exercise. In other words, the maturity was about a month option. So I'm going to simulate 10,000 prices in March, get 10,000 payoffs, take the present value of those, and simply take the average. And if it's for a put, I'll use X minus ST. And my spot price guess is going to use this random walk model. Now I'm going to use a function instead of typing in this nasty formula with the exponential function. I'm going to use this function called risk neutral stock sim, where I just put in the spot price, the interest rate, the risk-free interest rate, the dividend yield, the volatility, the T, and the Z. If you want to know why I'm assuming that stock prices only go up by the risk-free rate, go take a look at my last video in this topic. You can see my risk-neutral stock sim is simply that spot price times E to this big long factor written in here. And if I'm going to do simulations in Excel, that Z I'm going to simulate using my norm S inverse random function or formulas. Now the underlying information for this option. Today's date was February 28th. The maturity date was March 17th, which turned out to be 18 calendar days. If I take that 18 calendar days, the difference between these two dates, divide by 365 days, that's 0.049 years. I'll just point out that another way of doing the fraction of a year is to simply do business days. There are 13 business days, and there's about 252 business days in a year. So I could have taken 13 over 252, but I'll take 18 over 365, which is 0.049 years. The spot price of the asset on this date, February 28th, was 614.27, and we're talking about a 615 strike call and put. At the time, the stock paid no dividend. The risk-free rate for 1 month is 0.1%. I'm going to guess a volatility of 30%. Again, these are the inputs to my model for my simulating of stock prices. Now, where'd I get 30%? Because I want to Google and I want to a graph of the moving average 40-day standard deviation, and it's been running right around 30% for the last couple months. So I'm going to use 30%, the standard deviation has been running for the last 40 days. So I'm going to go to my Excel and I'm going to go ahead and value this option using my simulated stock price. So here are the inputs. You can see that the T is 0.049. I have that reference to T right here. Now what I need to get my formula to work, I need a random Z. Notice I have at risk running, so I'm going to type in equals risk normal 0, 1. That gives me a random variable with a 0 mean, 1 standard deviation called a standard normal number, a random number. Notice 0 sits in that cell for now, because in at risk, when it's not running a simulation, it'll just put in that mean of 0. And then I'll do this formula here where I'm going to start with a price of 614 and generate 10,000 possible stock prices based on 10,000 shocks based on as a factor of the standard deviation. But instead of typing in this formula, I've created that function. In VBA, I've typed in my function. I'll do user define. Again, you can look up the last topic to see the actual code of this topic. And I called it, what did I call it? I called that risk neutral stock sim. So there's my function. I'm going to select that function and put in the current spot price 614, the risk-free rate of 10 basis points, the dividend yield of 0, the volatility of 30%, my T 0.049 years, go down a little bit and get my random Z. So right now this formula is using a Z of 0, and you get 612.94 based on this formula. And then I'm going to put the payoff, the present value of the call payoff. So let me just type in the call payoff, max 0, simulated spot price, minus the strike. I'm going to anchor that, well, I don't need to anchor that. So that's the payoff of a call based on 1 iteration. And I'm just going to take the present value of that by multiplying times EXP to the minus R times T. So that's the present value of the call payoff based on this simulated stock price. I'll do it again here for the put, max 0, strike minus simulated spot times EXP to the minus R times T. So here's the present value of the put payoff based on a random Z of 0. Now what I'm going to do is I'm going to generate 10,000 of these random Z's, and then when I'm done, I'll have at risk, my simulation add-in is going to gather all those iterations, and what I'm going to do is just take the average of those 10,000 present values of payoffs. So I'll just say equals risk mean, click on the call payoff, I'll copy that formula here, risk mean, and then I also need to make these at-risk outputs. So I'm going to select both these cells, add output. So now I have 2 outputs, I got 1 input, and then what I'm going to do is I'm going to run 10,000 iterations. That's already set to 10,000. At risk is going, it's starting to generate those 10,000 numbers in cell E3. Then it generates 10,000 present value of call payoffs, 10,000 present value of put payoffs, and the Monte Carlo model says the value of the option is the mean or average of those 10,000 possible present value of payoffs. So let me just let this finish running. There we go. It's a little slow because I have some other at-risk models in these other worksheets, and anytime you run at-risk in a spreadsheet, it's going to run all of your simulations that are in that spreadsheet. So you can see here's the histogram of all the present value of payoffs. You can see a lot of times it happens to be 0. What this is about half the time this option turns out to be out of the money. So about 50% of the time the payoff is exactly 0. However, the other 50% of the time you make money, and it looks like you make between, say, a little bit over $0 and maybe $150, $160. So the average of all these payoffs, if I look at the mean, is $15.98. That is my Monte Carlo valuation of this call. It is the average of 10,000 possible call payoffs, assuming stock prices are normally distributed with this standard deviation of 30%. And the expected return is only the risk-free rate. Again, talking about risk-neutral pricing here. So there's my mean of that distribution. I don't have to just look at the graph. I can say risk mean, point at an output, and it'll tell me that. And it says this put should be selling for $16.68. Now the market prices of these options were about $10. So it looks like these options might be pretty valuable. If I think they're worth about 16 and they're only selling for 10, maybe I'll buy them, and I'll talk about that in a topic in the future, how it would have turned out if I would have bought these options. So I've just calculated the Monte Carlo valuation of the call and put, and they're about $16 each. Now I just want to show you one way. If you don't have the at-risk software, you can do the same thing, and you just use a macro and a macro using my Excel. So it's in the next worksheet. It's in the same worksheet. It's just a little bit farther down. So what if so this is the at-risk valuation. However, instead of using risk normal 0, the at-risk random standard normal number, I can use Excel's approximation of that, and that is norm S inverse rand, close that off, and this is an at-risk approximation for normal distributions. Notice I'll keep hitting F9 here, and every time I do I get a new random number. If I did this 10,000 times, what you would notice is what you'd see is the mean of these 10,000 numbers are 0 and the standard deviation is 1. I can then use my function. And what I'm going to do is simply calculate or copy this one. I'm going to anchor everything by hitting F4. I'm going to copy that formula down here. That's my stock sim formula. That's basically this formula right here, except I don't want to reference this random Z. I want to reference this random Z. So now every time I hit F9, I get a random stock price for Google in March. And now I can use my formula right here. I'm going to copy, well, let me anchor all this. I'm going to hit, whoops, I can't do that because that has the at-risk output in there. So I'll just type that one in there. Equals max 0, comma, simulated spot price minus the strike. I'm going to anchor the strike times EXP to the minus R, anchor that, times T. Anchor that. So here's the present value of the call payoff based on this random Z. I'm going to copy that formula down and just make one adjustment. I'm going to make that simulated price here. And also for a put, it's going to be before the strike minus the simulated spot. So I took strike minus simulated spot, B4 minus B14 instead of B14 minus B4. So this is my simulated call payoff, present value of simulated call payoff, and this is the present value of the simulated put payoff. Now what I'd like to do is take this number, calculate it 10,000 times, and record that value right here, and this would go down for 10,000 possible numbers. And then I'd take this number here and calculate the 10,000 possible put payoffs. Now I wrote a macro called simulate 10,000, And it's a simple loop, and you can learn about what this loop means if you look at my early topics on advanced VBA. And I simply did a loop for I equal 1 to 10,000, next I. I did a countdown in this cell to see how fast you're going. And then I took whatever is in this cell and put it here, and then here, and then here. I took whatever's in this cell and I put it in here, and here, and here. That's these 2 lines of code. I attach this macro to this star, this art object, and I'll run it, but I'm not going to run it now because it runs a little fast. Maybe when I say goodbye, I'll have it running in the background. So maybe that's a good time to end this topic. The last step is I'm going to just calculate the average of my 10,000 calls. So I'm going to take the average of those 10,000 numbers there. I'm going to take the average of my 10,000 possible put payoffs after I ran this function. I'm hitting Control-Shift-Enter to get the end of a range. And you can see here that I get pretty close to this Monte Carlo model using at risk. 1598, I get 1594, 1668, 1648. And that's the difference, is that this is an approximation for that standard normal number. I think I trust at risk a little bit better in getting those standard normal random variables. So I consider this probably the best, and maybe if I did maybe 100,000 iterations, that this Excel approximation would be a little bit best. So in this topic, we calculated or used a Monte Carlo at-risk model to value a call option and a put option, and then replicated that in just an Excel model using a macro to calculate this number 10,000 times. So that'll be it. As I finish off here, I'll just go and run my macro, and you can see that the numbers quickly fill up here and here